Hi everyone, and welcome back to the channel. Today, we're diving deep into a topic that sounds like it's straight out of a blockbuster movie, a massive, silent shift happening under the biggest ocean on Earth, and what it might mean for some of the planet's most powerful volcanoes. We're talking about the Pacific Plate. So grab a snack, get comfortable, and let's explore this together. First, let's do a quick refresh on plate tectonics. Imagine the Earth's surface isn't one solid piece, but is broken up into giant, rigid puzzle pieces called tectonic plates. These plates are constantly moving, floating on the semi-molten layer of rock beneath them, called the mantle. Think of them like massive rafts on a very, very slow-moving river. Most of the time, this movement is incredibly slow, just a few centimeters a year, about the same speed your fingernails grow. But it's this movement that causes earthquakes, creates mountain ranges, and, you guessed it, fuels volcanoes. Now, the star of our show is the Pacific Plate. This thing is the absolute giant of the tectonic world. It's the largest plate on Earth, covering almost the entire Pacific Ocean floor. And it's surrounded by what's famously known as the Ring of Fire. This isn't a fantasy realm, it's a massive, horseshoe-shaped zone that stretches all the way from New Zealand up through Indonesia, Japan, across to Alaska, and down the west coast of the Americas. Why is it called the Ring of Fire? Because about 75% of the world's volcanoes and 90% of its earthquakes happen right here. It's the most geologically active place on our planet. The reason it's so active is because the Pacific Plate is constantly interacting with the plates around it. In most places along the Ring of Fire, the Pacific Plate is being forced underneath its neighbors in a process called subduction. Imagine two conveyor belts meeting and one slides down under the other. As the Pacific Plate dives down, it gets superheated and parts of it melt, creating magma. This magma is less dense than the surrounding rock, so it rises to the surface, and boom, you get a volcano. This is how famous volcanoes like Mount Fuji in Japan and Mount St. Helens in the United States were formed. So, we have this massive plate, constantly moving and grinding against its neighbors, creating all this geological drama. But recently, scientists noticed something unusual, something big, and strangely quiet. Using incredibly precise GPS sensors and satellite data, they discovered that a huge section of the Pacific Plate, an area roughly the size of Australia, is behaving weirdly. Over the last several years, it has been shifting horizontally, rotating ever so slightly, in a way that's different from its long-term, predictable movement. Think of it like this. You're steering a huge ship on a set course. You know it's moving forward at a certain speed. But then you realize the whole back half of the ship is slowly, almost imperceptibly, starting to drift sideways, independent of the ship's main direction. That's essentially what's happening with a massive chunk of the Pacific Plate. It's a subtle, silent shift, a slow-motion twist that we wouldn't have even been able to detect just a few decades ago. Scientists are calling this a torsional deformation, which is a fancy way of saying it's twisting. Now, you might be thinking, okay, a giant piece of rock is twisting a tiny bit. Why should I care? Well, here's where it gets really interesting and connects back to those megavolcanoes. This silent, large-scale twisting is putting new and different kinds of stress on the crust all along the edges of the plate. It's like twisting a ruler. For a while, it just bends, but if you keep twisting, the stress builds up, and eventually, it could snap. In the case of the Earth's crust, this snap could mean a major earthquake. But it's not just about earthquakes. This new strain could also be changing the plumbing systems of the volcanoes sitting on top. Remember how volcanoes are fed by magma rising from the subducting plate? Well, this twisting motion could be squeezing, stretching, or even cracking the underground pathways, the pipes and chambers that magma travels through. It could potentially change the pressure in the magma chambers beneath some of the world's largest and most dangerous volcanoes. This brings us to the term megavolcano, or more scientifically, a supervolcano. These aren't your average cone-shaped mountains. A supervolcano is a volcano capable of an eruption that is thousands of times larger than a normal eruption. We're talking about an event that could eject over 1,000 cubic kilometers of material into the atmosphere. To put that in perspective, the 1980 eruption of Mount St. Helens, which was a huge event, ejected about 1 cubic kilometer. So, a super-eruption is on a completely different scale. The most famous supervolcano is probably Yellowstone in the United States, but there are others scattered around the globe, including several along the Ring of Fire, like the Taupo volcanic zone in New Zealand. An eruption from one of these could have global consequences, creating a volcanic winter by blocking out sunlight with ash, which would drastically affect climate and agriculture worldwide. So the big question is, could this silent shift of the Pacific plate be the nudge that wakes up one of these sleeping giants? The short answer is, we don't know for sure, but it's a possibility that scientists are taking very seriously. Here's the logic. A change in crustal stress can do one of two things to a magma chamber. It could compress it, squeezing the magma and potentially triggering an eruption. Or it could create new fractures, allowing magma to move to new places or making it easier for it to reach the surface. It's like squeezing a tube of toothpaste. A little pressure and nothing happens. A bit more and you might get a little out. A sudden, hard squeeze in the right spot? The cap could fly off. What makes this so complex is that we're dealing with forces on a scale that is almost impossible to comprehend. This shift is happening deep within the Earth, over an enormous area, and over a period of years. The effects aren't immediate. It's more like a slow-building pressure cooker. The silent shift is turning up the heat and adding a little more weight to the lid, bit by bit. Now, before anyone starts building an underground bunker, let's be clear, this does not mean a super-eruption is imminent. Geologic time is long. Soon for a geologist could mean in the next 100 years, 1,000 years, or even 10,000 years. What this discovery does is give us a new, crucial piece of the puzzle. It tells scientists that there are massive, plate-wide forces at play that they hadn't fully accounted for before. This new understanding is helping them refine their models for predicting volcanic activity and earthquake hazards. By tracking this silent, twisting motion with ever-improving technology, they can get a better idea of where stress is building up the most. It's like getting a weather forecast for the Earth's crust. It's not perfect, but it allows us to see the storm clouds gathering long before the storm hits. For example, scientists are now re-examining areas along the Ring of Fire that have been unusually quiet. Sometimes, a lack of earthquakes in a very active zone isn't a good sign. It can mean that a fault is locked, stuck, and building up an immense amount of stress that will be released all at once in a massive earthquake. This new data on the plate's rotation can help pinpoint which of these quiet zones are the most concerning. Similarly, they are monitoring the volcanoes that lie within this twisting region more closely than ever. They're looking for tiny changes, subtle ground swelling, changes in gas emissions, or tiny tremors that could signal that the magma below is on the move. This silent shift provides a context, a reason to pay extra close attention to certain symptoms. So, to sum it all up, the largest tectonic plate on Earth is slowly, silently twisting. This massive movement is changing the stress patterns across the entire Ring of Fire, the most volcanically active region on the planet. This could potentially influence the behavior of the massive magma systems that feed supervolcanoes. It's a powerful reminder that our planet is a living, breathing, dynamic system. We live on its thin, fragile crust, and beneath our feet, forces of unimaginable power are constantly reshaping our world. We can't stop these processes, but by understanding them, we can learn to live with them more safely. This discovery isn't a reason to panic, it's a reason to be fascinated and to appreciate the incredible science that allows us to peek into the heart of our planet. What do you think about all this? Does it blow your mind that a chunk of the Earth the size of a continent is slowly twisting under the ocean? Let me know your thoughts down in the comments. I'd love to hear what you think. Thanks so much for hanging out and exploring this amazing topic with me today. If you enjoyed this journey into the Earth's depths and want to learn more cool stuff about our world, make sure to hit that like button and subscribe to the channel so you don't miss our next adventure. We'll see you in the next video.